Let's make things more interesting. Let's use 3 equations and 3 unknowns. Graphically speaking, if we have 2 equations and 2 unknowns, what we're talking about are lines and where lines intersect. But with 3 equations and 3 unknowns, we're talking about planes and where planes intersect. So if you think about a plane as a wall, then you can imagine 3 planes coming together to form a point. That is, if you look at the corner of your wall and the ceiling, you see where 3 planes intersect. So our goal is to solve for x, y, and z, which gives us our point of intersection for these 3 planes. We have the option of what variable we want to eliminate first, and I think after taking a moment and looking at the x's, the y's, and z's, I would like to eliminate the x's first. So the plan is eliminate the x's and then look at what we have left. I think we should start with the first equation and the third equation. We want to combine those together to eliminate the x's. But in order for the coefficients to match up, I need -2 times the first equation. So here's -2 times the first equation, and then copied down the third equation. If I combine these, I end up with 0 x's. That was the whole point of doing what we're doing. Get rid of the x's. Minus 4y minus z is equal to 7. So that's our first new equation. Great. But in order to work with this, I need another equation where the x's have been eliminated. So if we look at the first 2 equations, we see that we need to eliminate 4x, so I need to multiply that top equation, equation 1, by a -4. Taking it and multiplying by a -4 gives us -4x minus 4y plus 4z plus 4 is equal to +4. So now, adding these two together, the x's cancel out, which is what we want. And now we have minus 7y plus 6z is equal to 20. All right, so now what we're looking at is we're looking at an equation, 2 equations with 2 unknowns. So I've got my equation 4, I'm going to call this one, the top one, equation 4, -4y minus z is equal to 7. And my new equation 5 is going to be a -7y plus 6z is equal to 20. Now we can move on to this problem. We want to eliminate one of these variables. Notice if I want to eliminate the y's, I'm going to have to get the least common multiple of 4 and 7, which is 28. That's kind of a large number. But if I want to eliminate the z's, then the least common multiple of those would be a 6. So we just need to multiply equation 4 by 6. So we have -4 times 6 is 24. Y minus 6z. 4 times 7 is 42. And now I'm going to eliminate the z's by adding those two together. We have -31y. The z's are eliminated, is equal to 62. Now I can solve. By dividing both sides by -31, we have y is equal to -2. That's great news. Now we can substitute back into one of our previous equations. Now, when we substitute this back into the previous equation, we only are interested in substituting it back in equation 4 or equation 5, since those have y's and z's in it. I think it looks to me like equation 4 is easier to work with since it has smaller numbers. So I have negative 4 times my y, which is negative 2, minus z equals 7. Now we have to solve for z. And it looks like I have an 8 minus z is equal to 7. So z equals 1. Now that I have y and z, I can go back a step to equation 1, 2, and 3 and find an equation that I want to use to solve for x. To me, it looks like equation 1 is going to be the easiest one to solve for x. So we have x plus y minus z equals negative 1. So what does that give us? That gives us x minus 3 equals negative 1, or x equals 2. So our solution is the point x equals 2, y equals negative 2, z equals 1. What's very important about this question is that we stay organized. The way I like to do this type of problem is kind of work from left to right and top to bottom. Use the first, you can kind of think of this as a column 1. And this is where I'm dealing with 3 equations and 3 variables. And then once I get a letter eliminated, I move them over here to column 2, and that's where I'm working with my 2 equations and 2 variables. If you want, you could do the back substituting in column 3. I just didn't want to make it too wide. But then here's my back substituting right here. And if you stay organized, it definitely helps. Also, another thing that I would point out is, notice my x's are all lining up, my y's all line up, my z's line up, and my numbers line up. That's another way to kind of look back and stay organized. Over here, my y's, my z's, and my numbers line up. It'll help if you have to look back.